Okay. Hey, everybody. I'm going to share my screen here. All right. So today is day 7, so June 9th. So if you haven't finished the uh, chapter 3 review worksheet, those are due tonight at 6. So if you haven't watched 4.3, the extra example is there in the lecture notes. It's embedded in that page. So you can just watch all the videos there. But today is day 7. So we have two things to look at today. We're going to do the another chapter 2 project. So those are starting to get very familiar for us. And then we have a cumulative review. So you can see here that we're going to have 3 cumulative reviews before we do sample midterm. Um, the cumulative review uh, is this first one is chapters 1 through 3. We've finished chapters 1 through 3. We've already finished the material for chapter 4, but we haven't really started doing, uh, you know, a lot of projects around them. So next time we'll do chapter 4 review, and then we'll be able to do some cumulative review around that. So um, the midterm is going to cover chapters 1 through 5. Okay. Um, so we will start chapter 6 before the midterm, but we're not going to do chapter 6 on the midterm. Okay. But we'll do 1 through 5. So today you're getting assigned the 5.1 lecture notes. So this is our first step into chapter 5. Um, if you've already watched those and finished that, that's great. Um, I have gone through and graded a lot of stuff. I've finished grading both of the review worksheets that we've finished. So we did a chapter 2 review worksheet and a chapter 3 review worksheet. So both of those have been graded. And a lot of projects I've graded as well. Um, I haven't gotten through everything, but uh, yeah. So, um, all right. So. Uh, Chapter 2, Project 8 is very similar to the other Chapter 2 projects that we've looked at. So relative frequency, midpoints. Remember that I want to see the formulas for the midpoints, okay? I don't want to see just the number. But if you click on Chapter 2, Project 8, and then you click on the link, it'll bring you, oh, that's not right. Yeah. It'll bring you here. And then you'll click on this link in the Google Doc, and that'll bring you to our data. You'll make a copy. But I'm going to have you guys work on this together in our groups um, in a little bit. This is tied to the cumulative frequency, or sorry, cumulative review, not cumulative frequency, cumulative review. So the cumulative review is actually what I want to start with. Um, So, cumulative review number 1, you'll find that in your course pack on page 373. The reason I want to start with it is because on one of these pages, we're actually going to use the data from the project. So, um, on the second page, this is the same data that you'll find for Chapter 2, Project 8. So when we get to this, we'll pause, we'll do Chapter 2, Project 8, and then we have some questions about that stuff, okay? So similar to previous worksheets, I'm going to give you lots of hints, especially on the big ones. But might not give you all of the answers right here. So we will have this worksheet finished by the end of the day, though. So we're going to work on it a little bit together. Yeah, page 373 in your course pack. Okay. Um, this is the first cumulative review. Okay. Cumulative, by the way, we've learned what cumulative means, right? It's um, adding up everything up to this point. Okay. Just like cumulative frequency, it's you add up this class plus everything below it. Okay. So cumulative chapters 1 through 3. Make sure you put your name on this. I know it's kind of dumb, but when you uh, scan this in with, Genius Scan or Cam Scanner, um, it really helps if I have your name on there because often I have to download them and then to grade them. And then if I don't have the name in the document, then have to figure it out based on, you know, uh, the name of the worksheet. So anyway, not that there's points or anything. I've been able to figure it out. But if you do look at your grades and you're like, wait, this doesn't make sense. Why is my grade this? Let me know. I'd be happy to walk you through it. Hopefully, I didn't mess anything up where someone's name was missing. Gave the grade to the wrong person. I don't think that happened, but okay. So, uh, for this first one, there is a link for StatCrunch, which will let you get this data. So, uh, let's if you here in Canvas, go click on the cumulative review worksheet number 1. Uh, there is a link right here that's going to take you to StatCrunch. Okay. And here's the data for it. Okay. So we will only need that for one of the questions. But there you go. So, um, and I think everyone on the call here this morning has been able to get into StatCrunch. We've had at least one person who was struggling with it. So hopefully Elaine and Cindy were able to help get that figured out. If not, let me know if you're still struggling to get into StatCrunch because you're going to need it for the exam. Um, so let me know if you're still struggling and we can set up some time and work on it together. Okay, so jumping back over here. Um, so some of these ones should be pretty easy. Um, okay. That one's fine. All right. I want to look at this one first. E. Um, what is the probability of a country having an incarceration rate of 400 or more? Okay. So this is giving incarceration rates by country. Okay. What is the probability? So probability, okay, is going to be a fraction. Okay. A probability is a numerator and a denominator. Okay. The numerator is going to be the thing that you want to have happen, and the denominator is going to be total number of outcomes. Okay. So in this case, what's the probability of a country having incarceration rate of 400 or more? So here's 400 right here. Okay. So or more, we would just add these numbers up. Okay. So your numerator is going to be 400 or more. Okay. And you'll do the sum of that. So I'm going to use just the symbol right here. Uh, oh, you guys can't see that. There we go. Probability is on the new is a fraction in the numerator. I'm going to put the sum, which is this sigma. Okay. You're going to sum up everything from 400 or more. Okay. Divided by total. Okay. Total is add them all up. Okay. Should be no problem. Uh, 1F. All right. The US is in the 98th percentile for incarceration rates of countries worldwide. Interpret, interpret what this means in the context of the situation. Okay. So that means that uh, The U.S. has the U.S. has an incarceration rate that is greater than or equal to 98% of the U.S. has an incarceration rate that is greater than or equal to 98% of the other countries. Okay. So, in other words, what that means is um, out of all the countries in this list in the world, okay, in this case, the population is the world, but uh, so there's only 1%. So at 98%, anyone that's at the same bucket as us, we count as equal to. So it's only the people in the 99th percentile that have a higher incarceration rate. Okay. All other countries are below. U.S. has an incarceration rate that is greater than or equal to 98% of the other countries. Okay. All right. Let's move. Let's move on. Let's see. One second. I need to. All right. So for this one, for number two, I mentioned earlier, this is our chapter two project date, okay, which we'll work on in a second here. Um, and I'm going to give you just some. So after you've finished this and filled all this in from the project, there's questions. I'm going to jump to F. All right, so F. What is the probability that a random country has less than 44.9 megabits per second? Okay, so this is looking at internet speed by countries in the world. So what is the probability that a country has less than? So again, probability is equal to the total number of wanted outcomes divided by the total number of outcomes. Okay. So in this case, we want less than 44.9. So here is 44.9 right here. Okay. So less than would be all of that. So you'd add those up. Okay. So those are our wanted outcomes divided by total number of outcomes. Okay. And so probability is always going to give you a fraction or a decimal or a percent. Okay. Those are all interchangeable, right, in math. So usually we talk about percents or decimals. Okay. So here, give me three decimal places. So if your answer is, 0.123, I'm fine with that. Okay. That's not the answer, but I want three digits after the decimal. Okay. All right. For H, treating this distribution as a population, give two decimal places. Okay. Find the mean and the unadjusted standard deviation. Okay. So to do that, what we need to do is on page 232 in our course pack, we use method 2. Okay. Page 232 in your course pack, that was this yellow exam notes packet that you can use for the exam, right? And on page 232, on the second page, there's a couple different ways to find means and standard deviations. If I have the raw data meaning I just have the actual list of the numbers, then I can use summary stats columns in StatCrunch and find standard deviation. That's not what I have for this one. Okay. I have a bunch of frequencies. Okay. I can build a histogram with this, right? These are grouped, these are binned. Okay. So in order to do a standard deviation for that, I'm going to use from a frequency distribution, summary stats grouped binned. Okay. And I want the unadjusted standard deviation. Okay. We haven't talked about method 3 yet, which is for discrete probability distribution. Okay. So for now, though, for this one, we're going to do on page 232, use method 2 in StatCrunch. Okay. And then interpret these values in the context of the situation. So for this, we're going to use the page 231 give or take script. Okay. So it's going to say something about like the internet speed of a country is going to be the mean, give or take the standard deviation. Okay. Okay. All right. Next page. Okay. The following shows the energy consumption for a random sample of countries in 2021. So these would be raw data. Okay. These are not grouped together. So if they were grouped, we'd have like maybe from, 0 to 5, and then from 5 to 10, or I guess it'd be 0 to 4.9, right? 5 to 9.9, 10 to so on and so forth. And you'd have a count of how many of each of those fall in that bucket. Okay. We have the actual raw data here. So for this first one, find the following. There is a link again where you can go get this data in StatCrunch. So, and that's right here, the energy consumption right here. So again, I went to in Canvas, I clicked on cumulative review worksheet, clicked on this for StatCrunch. It brings me here, and here's my energy consumption for this question. Okay. These over here were for the um, question number 2, right? The project one. Okay. So they're not related to this column. Anyway, in here, I can use um, once I've signed in, I haven't signed in yet, but once I've signed in or registered, I can use summary stat columns, and then select my energy consumption and select which things I want. Okay, I want all of this. So mean, median, mode, standard deviation, variance, all of that good stuff. Okay. All right. Once I have that, I want my lower fence. Okay. So to calculate the lower fence, it's whatever the number for quartile 1 is, first quartile, minus 1.5 times my interquartile range, whatever that is. Okay. So you need these two numbers in order to calculate your lower fence. Upper fence, same thing, except it's plus, and it's 1.5 IQR, and it's the third quartile. Okay. And the upper fence and lower fence, those will allow you to tell if there are outliers. Okay. Anything lower than the lower fence, anything above the upper fence, we consider an outlier. All right. So shape of the distribution, I'll let you guys figure that one out. Okay. Um, this one, 3E. So um, I'm gonna I'm gonna help you with this one because this one is talking about z-score. Okay, and z-score, in my opinion, is a tricky concept. Okay, so um, I a z-score is is how many standard deviations you are away from the mean. Okay. So in other words, we're looking at 5.6 exajoules. Okay. That's our X value. Okay. That's what we're trying to compare to the mean. And we're trying to figure out how many standard deviations we are. Z-score, I mean, maybe it would have been better if they'd called it like an S-score because it's your standard deviation. It's how many standard deviations away you are. Um, so to do that, we need Z-score is equal to my data point, okay, minus the mean divided by standard deviation, okay? Now, uh, there's two ways you could do it. So mean, sometimes we talk about population mean, so we use mu. Sometimes we'll talk about sample, in which case we use X bar. Okay. It's the same thing. Okay. Whatever your mean is for your data set, you're not ever going to have the mean of a population and the mean of a sample. Okay. If you do, then there's no point in having the sample. The purpose of a sample in real life is there's so many data points, there's so many people in the world or whatever population you're looking at, it's not possible to get a mean. And so you have to take a sample. Okay. Um, if you have the resources to calculate the mean of the entire population, there's no point in having a sample. Okay. So anyway, regardless, there's two formulas for z-score. They both are using mean and standard deviation. Either letters are fine. X bar, mu, sigma, s, whatever. Um, so to do this one, I'm actually going to give you the answer for part of number three. We need the mean, we need the standard deviation. So once you go into StatCrunch and do the calculation, you're going to get this for the mean, 23.555. Okay. And the standard deviation is going to be 37.230. Okay. So I'll give you those right now. The other ones you're going to have to figure out on your own. Okay. On StatCrunch. All right. So uh, we are asking find the z-score of Spain, which uses 5.6 exajoules. Okay. Um, so in my z-score here, I'm going to do z-score equals the data in this case is the thing I'm comparing against the mean. So that's my 5.6. My mean is 23.555. And my standard deviation is 37.230. Okay. Keep in mind that every fraction has invisible parentheses around the top and bottom. You know that they're there, but when you type this into Desmos, it's not going to know that they're there. So you're going to need the parentheses. Okay. Um, I don't have Desmos open, so let's see here. Mm, should have opened that earlier. While that's thinking, I'm going to jump back over here. Um, so this is going to give you a negative number, okay, which is fine, okay. Um, you can think of a z-score. So z-score is taking your data and breaking it up into standard deviations, okay. Um, just like how percentiles take your data and break it up into 100 pieces, 100 buckets, you can think of quartiles taking your data and breaking up into 4 pieces. Standard deviation is going to take your data and break it up into buckets called standard deviations. So you can have one standard deviation. So from the mean up to one standard deviation. Okay. You can have below the mean, which in that case would be a negative z-score. Okay. So instead of your percentiles going from 0 to 100, you have standard deviations that go from like -3 up to +3. And actually, it goes farther than that, right? You could have standard deviations way out there past 4 or 5 or below negative, you know, negative numbers. So that's the way I like to think of it. So anyway, I'll leave this one for you guys to calculate just for the sake of time. But let's move on to this last page and we'll talk about this. So if your data looks like this, it looks normally distributed, then this one right here will be your mean, and then right here is going to be your first standard deviation. So we remember this was 34%, right? So I want you to fill in all these numbers. Okay. Here's 2 standard deviations. Here's 3 standard deviations. Okay. Yeah, so if I was doing this as percentiles, instead of having it split like that, I'd have 100 little pieces, okay? 100 lines. Or if I had quartiles, this would be my median. Here's quartile 1, here's quartile 3, right? Standard deviations are the same kind of thing where you're breaking it up. So this would be a z-score of 0 right here, z-score of 1, 2, okay? You don't need to put the z-scores in there. I want the actual numbers, okay? That's the idea behind a z-score. All right. Um, so mu would be 48. So here's 48 right here. So if I go up by 11, I'll be at 59. If I go down by 11, I'll be at 37. Okay, so fill in all of those. Okay. For this one, 99.7% of air conditioning repair times are between 1 and 1. Okay. So 95% would be 2 standard deviations away. 99.7 is 3 standard deviations away. So whatever number you have here in your third one, and whatever number you have here, those are the numbers you're putting in this spot, okay? So those are the numbers we're going to want to remember is 99.7 is 3 standard deviations, 95% is 2 standard deviations, okay? All right. You guys should be able to do that one, should be able to do that one. Uh, all right. What is the cutoff for an unusually long air conditioning repair time? So generally we consider 2 standard deviations to be usual, and anything outside of that is unusual. Okay. So that means that if my z-score is between 2 and -2, I consider that usual. Okay. You might not want to write it like this. Maybe you want to write it as absolute value. Z-score is less than 2. I find that confusing. Basically, if my z is above 2 or below -2, I consider that unusual, right? That's a person that's very tall, or that's a person that's very short, or in this case, repair times, that's, the guy showed up and he fixed it in a second, okay? Or the guy showed up and it took him, what is this minute? This is 59 minutes, so it takes him like, 3 hours. That's a long repair job, okay? So that doesn't happen very often. It's unusual, okay? Um, okay. So all right, these ones you should be able to do. By the way, this is not number 3. This is number 5. This doesn't matter. Whatever. Um, okay. I'm not going to take any more of your time because I want you guys to work on these together. So I think I'm giving you some big hints. I'm going to stop my screen share here. Um, and I'll mute my mic and everything. And I'm going to let you guys work on this cumulative review and the project. And Elaine and I will be here if you get stuck. Okay.